In this video, we start implementing the event loop. So event loop, as we all know, we discussed in last video, is something that JavaScript uses for executing stuff and how it kind of is able to get its async nature even after being single threaded, right? So this is what we discussed in the last video. I'll link it somewhere here. If you haven't watched it yet, you can go watch it. I'll just give a quick walkthrough. So what happens is when you have some task, it's pushed to the main queue, and from the main queue it forms a long queue here. Once the queue is once event loop is ready, it pulls tasks from the queue, executes it, it's done. Pulls the next task from the queue, executes it, it's done. So since it's a queue, it's first in first out, so whatever comes first goes out first. So as simple as that. Then if there is anything async involved, then what it does is it would delegate it to the web APIs. Let's say there's some promise or some set timeout function with some callback and stuff, and every async process like that's here will have a callback. So web API will take the responsibility and it will keep on fetching the task so that it's not being occupied or blocked. The main thread is not occupied or blocked when everything is going on. The web APIs will process it. It will then again push whatever callback it had, like let's say after 10 seconds do X. That do X part, once the 10 seconds is done, for async kind of thing, you get the idea. So what it will do is it will again push it to the end of the main task. It will again wait for its turn. It will go ahead and it will be consumed by the event loop and execute. That's right. So that's how basic thing work. And for the micro task queue, let's say every main task have some small micro tasks which kind of go to the micro task queue, and there it gets executed along with the main task, right? So that's what and in this let's start with the implementation of it and see how we can kind of get the hang of it, right? So since we are kind of focusing on an event loop and it has like similar properties we discussed, like what does the event loop has? It has a main queue, it has a micro task queue. What else does it has? Let's see. It has the web API and it has the executor which maybe looks for pulls items from the queue and executes or delegates, let's say. So these are the behavior that we want to emulate here. So it will be a very simple implementation. So let's start with a class of event loop, right? Let's say we call it simple event loop or something. Let's call it something else. That's a very weird name. Let's call it, I don't know, XYZ so let's start with a class, and let's call it my brand new event loop or something, I don't know. So here we have this. It will have a constructor. The constructor will have its properties initialized with maybe the main queue. Let's say main queue. So we have the queue here. Let's start with this. Let's not focus on this. Let's start with the main queue first, and let's start with the executor first. So what's the functionality that we are trying to get out of here is there will be a main queue, and we should be able to start the event loop and run the processes and execute them, whatever is pushed to the main queue. Let's keep this away for now. Let's focus on this first. So we have this constructor and we have the main queue, and let's say we have another thing called maybe start execution or something. So what start execution will do is, as we discussed, so the executor will pull items from the queue and executes or delegates. So we don't have delegates as of now, since we don't have anything concrete for web APIs. So for web APIs, the delegation part would come in that, like, if there is something that needs to be async, just delegate it to the web API. It will do whatever async stuff it needs to be done, and then it will push the callback again to the queue, which is not async. So yeah, so delegation we can do later. Let's start with this and execution till there, this part. So what it would do is, like when it starts running, then what will happen. So let's see, let's have a variable call maybe this dot running or something is true. Okay, so this dot running is true. Let's see. So it's running by default, and when we have while this dot running, we pull the task const task equal to this dot main queue dot shift. So shift will basically first in first out thing, right? So whatever comes first, it will put in the last element, and we get the task. We execute it, and then we check if the queue is empty, because we don't want to keep it running, right? So it auto completed this for me. So we check if the length of the queue is 0. If it's 0, then everything is done and dusted. So we don't want to have to execute it again and again. So this is what the basic like queue structure that you can follow would look like, right? So you have to start it somewhere. It gets all the processes, it executes it, and it's done. So let's start by initializing this, right? So let's do this. Let's do const my event loop equals to new, what was the name? Okay, brand new event loop. So whenever we do this, this will be automatically initialized. So every event loop has like needs a queue. So whenever you do this, this will be initialized since it's a constructor. And then we forgot the main thing only. There is no way to add tasks to it. So let's say we define that as well. Let's say we define add task. It expects a task or callback, and then what we do is this dot main queue dot push. We push the task there. So push will basically put it at the end of the queue, right? So that's why I push the task. And then maybe we do something like my event loop dot add task, I think. Yep, add task, and let's copy this a couple of times. Let's do this. Let's do dot return dot for each or something, for each x. We basically event loop, we add one task in the event loop, and maybe we do currently at I don't know, x, I think. Let's see. Now if we want, now let me check for any errors. Did we miss anything here? I don't think so. Cool. So here is what we have. We added 10 random tasks. So we are just defining a 10 element array, and we are traversing through all of it. And console.log currently at like whatever number is there, we are pushing it to the add task method. Using the add task method, we are pushing this callback to the queue, right? So let me call it something else. Add task to main queue. Yep. Let me call it this. So we have this, and then if we do my event loop dot, what was the name? Start execution. And if we start this, let's see what happens. Oops, what did I miss? Okay, so got it. So yeah, we just initialized an empty array. So that's what 10 element array, and everything is undefined there. So we fill it with maybe 1 or something, I don't know. Yeah. So we initialized an empty array. We filled everything with 1. Like we filled the array with 1, and for each element we executed everything to, we pushed everything to the main queue, right? So when we push everything to the main queue and we start execution, as you can see, there were 10 processes here, and we had 10 here as well, right? Another, I think, just for the sake of clarity, let's not fill it with this. Let's take the index so that it's easier to visualize. Let's put it in there. So like basically it would print 0 to 9, since those are the indexes we have, 0 to 9 currently at or currently executing 0 to 9. So as you can see, we push these callbacks to the main queue, We then started the execution, and when we start the execution, we set the running variable to true. And when this is running, it runs on an infinite loop, and it pulls in stuff from the queue and it executes them. And when it's done, it shuts itself down like on its own. Like we check if there is any more items in the queue. If there are no items in the queue, just like we set running to false so that it doesn't run on an infinite loop and continue to use the CPU when it doesn't need to, right? So this is a basic implementation of the event loop from the main queue perspective. We'll also go through this, like we'll try to implement a microtask queue and web API as well, if we can, and see if we can emulate the behavior here. So like this is not the actual event queue, it is not the actual event loop, right? But like the point of doing this implementation is you get to know the gist of it. Like inside this, these are the like data structures and all, right? So queue or like loops and whatnot. So you're just able to form the picture and like see things better and kind of see the behavior and the full picture and like what complexities might come up. So this is something, let's say this question wouldn't have come up if you were to, I don't know, if you were to not implement it maybe. So it's like, will the event loop keep running forever? Like no, it doesn't need to, because if there is no task in the CPU, if there is no task in the queue, why would it consume the CPU? Doesn't make sense, right? Same as the cook in the restaurant example that we took. So if there is no orders, the cook won't stay in the restaurant because it won't make sense for him. He would do something else or do something better, right? So yeah, that should be it for this video, I think. In the next video, we'll continue with the same implementation. We'll try to get the microtask queue done, and maybe after that we'll move to the web API thing, right? So yeah, that should be it for this video, folks. If you like it, if you like the video, if you found it helpful, share it with your friends, drop a like, drop a comment, and yeah, see you folks. Bye.